Hello there and welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at symmetric properties of roots. Sum, that is sum and then product of roots. By the end of this lesson, you should be able to find the sum and product of roots of any quadratic without solving it. You should be able to use the symmetric properties to evaluate expressions like alpha squared plus beta squared, 1 over alpha plus 1 over beta, and alpha minus beta all squared. You should be able to form a new quadratic equations given transformed roots. You should also be able to apply the sum or product relationship to real world and theoretical problems. And finally, you should be able to understand why these properties are called symmetric. Now, as we proceed in this lesson, you'll be hearing of these vocabularies. So I would advise that you pause at this moment and then try your best to quickly glance through before we start the lesson. Without much ado then, let's quickly proceed. Now, we have spoken so far about two ways we can write the quadratic functions. The first one being the general one, which is ax squared plus bx plus c equals 0. And then we also looked at the vector form, where we say we have our a into bracket x, then plus h into bracket, then plus a k. We studied how to write an equation in this form. This one is achieved using the completing of squares. Now, there's also another form we need to know in this lesson. And for that, it says, so this new one we want to look at says a quadratic function can be written as x squared then minus the sum of the roots x and then plus the product of the roots. So we have product of the roots Now the question is, how do we derive this? So for a quadratic function written in the general form, that is ax squared, then plus bx, and then plus c is equal to 0. Let's say we have solved and then we have the roots. The roots are simply the values of x at the x-intercept. Then if we are to call the roots alpha and then beta, then it simply implies that our x is equal to alpha and then our x is also equal to beta. This is what we usually get. Now what we want to do is we want to gradually derive our equation from these roots. With that, what I mean is, instead of x is equal to alpha and then x is equal to beta, we would have written it as x minus alpha is equal to 0. Then x minus beta is also equal to 0. This is how we would have written it before making x the subject, and then we say x is equal to alpha. Now usually there's a step before this as well. So it is written as x minus alpha, then x minus beta is equal to 0. So it is usually like this before we say, okay, then let's equate this first bracket to 0 to give us this. And then let's equate this second bracket to 0 to also give us this. Now, there's also a step before this. That is, we usually take this to multiply everything we have in this bracket, and then the alpha also does the same. So that becomes x into bracket x minus beta, and then we have negative alpha into bracket x minus beta, and that is equal to 0. We then open our brackets. So this gives us an x squared, then x times negative beta gives us a negative beta x. Then negative alpha times x gives us a negative alpha x. Negative alpha times negative beta, we have a positive alpha beta is equal to 0. So with this, we can rewrite that is, since we have an x and then an x here, we can group them so that we have x squared, then they both have negative. So negative, we can write it as beta plus alpha x, and then plus alpha beta is equal to 0. We can rewrite this as x squared minus into bracket alpha plus beta x, and then plus alpha beta is equal to 0. Now, what have we actually achieved? Remember, we said the roots of the equation are x equals what? Alpha, and then x equals beta. These are the roots of the equation. So what we've done over here, these are the sum of the roots, and this is the product of the roots. So indirectly, we have written our equation in terms of the roots. That is to say, x squared, then minus the sum of the roots. So sum of roots x, then plus the product of the roots. The product of the roots is equal to 0. Do you see this? If you have to compare this to the general equation, that is ax squared plus bx, and then plus c is equal to 0. You realize over here we have the coefficient of x squared being 1. So we want to achieve the same thing over here. So I'm going to pick this whole thing, and then we divide each and every term by a. So divided by a, divided by a, then divided by a, and then we do the same as well here. This a cancels out this a, and we'll be left with an x squared. Then for here we have plus b over ax, and then plus c over a, which is then equal to what? 0. Now let's compare this very equation, this one we have here, to what we have up here. So I'm just going to copy this, then let's bring it all the way here. Now with that done, what I'm also going to do is, let me just change its color. Now let's look at it carefully and compare. If you are to compare the coefficients of the various terms, then for x squared, the coefficient is 1, and it is the same as 1 over here. For x, the coefficient is what? B over a. But over here, the coefficient is negative into bracket the sum of the roots. If you have to compare these two, we have b over a, which is equal to the negative a plus b. If you want to make a plus b the subject, then we can quickly, or we can easily say negative b over a is equal to alpha plus beta. This is what we have here. The same way, these are the products, and we can equate it to the constant term here. So that would say the product of the roots is equal to what? C over a. This is the proof for x squared minus sum of roots plus the product of roots equals 0. We are saying the sum of the roots is equal to what? Negative b over a, and then the product of the roots is equal to what? C over a. Now, to prove what we've done here, let's actually take a function or a quadratic function, we know its roots, and then reverse engineer it to see if we would get back what this is claiming. So let's take the function x squared minus 6x and then plus 8. is equal to 0. When you solve this, you get the value of x to be equal to 4, and then x equals 2. All right, so these are the two answers we'll get. Now, if the values of the roots are 4 and then 2, then let's see. Our equation from this side says the x squared minus alpha plus beta x, then plus alpha beta is equal to 0. That is to say, if we have the roots of our equation, and then we want the equation, you see, so this time we have the roots, and then we want to see if we can get back the equation. Substituting, we can simply say our alpha is equal to what? 4, and then our beta is also equal to 2. That is the roots, so you can just substitute any of them. With that, we have x squared minus, so it says alpha plus beta, that is 4, which we are saying is our alpha, plus 2 with our x, and then plus alpha beta, so that is the 4 times 2 equals 0. Simplifying, we have negative 4 plus 2 gives us a 6, then x plus 4 times 2 gives us an 8. And as you can see, it is just as our equation gave us. We use the roots to get back the equation. If you were to say you want your alpha to be equal to 2, and then your beta is equal to what? 4. Let's see if this can also give us the same answer. So once again, we have our x squared minus the sum of the roots. 2, this time around is our alpha, and then 4 is our beta. So 2 plus 4 with the x, and then plus 2 times 4. And you realize that they still gives us the same answer. So you have x squared minus 2 plus 4 gives us what? A 6. So we have our 6x, and then plus 2 times 4 gives us an 8 is equal to 0. So whether you let your alpha be this root or the other root, you would still get the same answer. That accounts for why we say this equation is actually a symmetric equation. It is a symmetric equation because if you are to change the value of alpha and beta, you are still going to get the same answer. Whether alpha was 4 and then beta was 2, or alpha was 2 and beta was 4, we still have the same answer over here. With that said, let's now answer some questions on what we have learned so far. So our first question we have here. So for our first question we have here, it says for the quadratic 2x squared minus 5x plus 1 equals 0, we have to find A, the sum of roots, and then B, the product of the roots. So this is to say, this is not to say we should go and then solve to get the sum, the roots of all the two before coming to sum them up and then coming to find their product. No, we want to use our equation we have worked on. So for our equation given in the question, that is for the quadratic, we have 2x squared, then minus 5x, and then plus 1 is equal to 0. And we know our equation is given as what? X squared minus the sum of the roots. So alpha plus beta, x, and then plus the product of the roots. So alpha, beta, and that gives us 0. So if you are to compare, what we have here to what we have here, then you realize that first of all, the coefficient needs to be 1. You see, we need to make sure the coefficient is 1, because it is only by so doing that we can do our comparison. So it simply implies that for the 2x squared minus 5x and then plus 1, which is equal to 0, we are going to divide this by 2, divide this as well by 2, and also divide this by 2. Same applies here. With that, we know these two cancels out these two to give us an x squared. Then negative 5 over 2, so 5 over 2x, and then plus 1 over 2 is equal to 0. So now that we have it in this form, we can now do our comparison. So for the coefficient of x, we want to compare them to each other. The coefficient of x here is negative alpha plus beta. So it's equal to the coefficient of x over here, which is negative 5 over 2. If we are to divide both sides by negative 1, we are going to get our alpha plus beta is equal to what? 5 over 2. As simple as that. Now for the constant term, so we have alpha beta being equal to what? Half. That one is just direct. So we have alpha beta, which is equal to 1 over 2. And then with that, we have been able to solve it. So it simply means the sum of the roots was what? 5 over 2, and then the product of the root was 1 over 2. Since we have gone through how to solve quadratic equations, you can solve to confirm. If you are to solve, you can then add and then multiply to see if you get the answers we have over here. So with that said, let's look at our next question. Now that we understand the basis of sums and then product of roots, we will now want to explore to get better understanding. So it says if alpha and beta are the roots of 3x squared plus 4x minus 2 equals 0, then we have to evaluate 1 over alpha plus 1 over beta. Now, for the equation 3x squared then plus 4x minus 2 equals 0, our roots are simply alpha and then beta. Now what we want is 1 over alpha plus 1 over beta. How are we going to get this? So with this, they are just testing your understanding on fractions. If you have 1 over alpha plus 1 over beta, you are not being asked once again to go and find the roots, to go and find what alpha is, find what beta is. No. But rather, if you are to simplify this, you know, if you are adding fractions, we work with the LCM. Now, since these are two different things, we just say our LCM is alpha times beta. So we have our alpha times beta, that is the product, all over. That is with a bar on top. Alpha divides alpha beta how many times? Beta. Because this alpha cancels out this alpha, then you are left with beta. So beta times 1 gives us a beta. Then we have beta also dividing beta, so that we'll be left with alpha. So plus alpha. This can be rewritten as alpha plus beta all over alpha beta. So you realize that what we are being asked to look for, which is 1 over alpha plus 1 over beta, which we would have thought we need to find alpha separately and then also go and find beta separately so that we can substitute and solve. It appears we can even use the sum of roots over what? The product of roots. So all we need now is the sum of the roots and the product of the roots. Our equation we have here was 3x squared plus 4x, then minus 2 is equal to 0. We know if we want to compare this, the coefficient of x squared has to be what? 1. So we are going to divide each and every term by 3. So that we have 3x squared divided by 3, then plus 4x divided by 3, then minus 2 divided by 3 equals 0 divided by 3. So that we are going to get an x squared then plus 4 over 3x minus 2 over 3 is equal to 0. And we said the minus alpha plus beta is what is equal to the coefficient of x we have here. So that is 4 over 3. And if you have to make alpha plus beta the subject, then we can say alpha plus beta is equal to a negative 4 over 3. On the other hand, if you want the product of our root, we know that is always direct. So alpha beta, which is the product, is simply 2 over 3, but then a negative. Because remember, we said the product of roots is whatever we have here as the constant. And since it's a negative value, then that is what we are going to get. So with that, we can then come and solve for this over here. We do that by substituting our values. So we know alpha plus beta was negative 4 over 3. So we have a negative 4 over 3. Then the alpha beta was a negative 2 over 3 as well. So we then want to simplify. This is simply a fraction divided by another fraction. So simplifying, we have what? Negative 4 over 3 divided by negative 2 over 3. We know when we are dividing fractions, we tend to do what? Multiply and reciprocate the other fraction. So if this is what we have, then we can simply say this 2 divides itself once, then divides the negative 4 twice, and then this 3 also cancels out this 3, you see. So that will be left with what? A negative 2 over negative 1. Negative 2 over negative 1 simply gives us a 2. It means our final answer, that is 1 over alpha plus 1 over beta, give us what? 2. And that is all. Now, if you would observe what we did, it means if you have your sum and then product of roots, and you are asked to evaluate some values, you will need to rewrite whatever you are being asked to evaluate in a form that you can easily find your sum and then product of roots. There are so many ways of doing that, and for some, you would have to memorize. So before the lesson comes to an end, I'll give you those that you would have to memorize. Now we have a new question here which says the roots of x squared minus 2x minus 5 are alpha and beta. You have to find a quadratic whose roots are 3 alpha and 3 beta. That simply means we have the roots of this equation, that is alpha and beta. But there is another one, there is another equation whose roots are the 3 times of this one we know. So if we know the root of that one, let's reverse engineer to get its equation. So first of all, what do? We have x squared minus 2x then minus 5 is equal to 0. The coefficient of x over here is 1. Hence it is already written as x squared minus the sum of roots x then plus the product of roots. So with that, if you want to compare, then you can easily say the sum of the root of this equation is what? Is that the negative sum of the roots is equal to whatever we have here. So it's equal to negative 2. So with that, we can simply say our sum of roots is equal to 2. Then we come to the product. So alpha beta, that is the product of the roots, is equal to the constant term we have here, which is what? Negative 5. So we have the sum of roots of this particular equation this one here, and we have the product of each root as well. How do we depend on this to get the sum and then product of the equation we don't know? So for our new equation, its roots are what? 3 alpha and then 3 beta. If we are to find the sum of the roots, then the sum of the roots is going to be what? 3 alpha plus 3 beta. Now this can easily be factorized as 3 into bracket alpha plus beta. Have we seen this anywhere? Yes. This is the alpha plus beta. You see, so it simply implies that the sum of the roots is going to be 3 into bracket the alpha plus beta, which is 2, and hence it is equal to what? 6. We've gotten the sum. What then is the product? So for the product of this root is going to be 3 alpha times 3 beta. That gives us a 3 times 3, which is a 9. So 9 alpha beta. We know what our alpha beta is, negative 5. So we have a 9 times negative 5, which then gives us a negative 45. So it means the product of this new equation, the product of its root, is a negative 45. So that is to say that we know the sum of roots of the new equation, and we also know the product of root of the new equation. In view of that, using the formula x squared minus the sum of the roots x plus product of the roots, then our new equation is simply going to be an x squared minus the sum of the roots. So we have the sum of the roots being what? 6. So 6x, then plus the product of the root. The product of the root is negative 45 equals 0. With this, let's do our necessary simplification. So we have our x squared minus 6x minus a 45 is equal to 0. As simple as that. So this here becomes our new equation. What did we do? We depended on the product of roots and then the sum of roots of our old equation to get that of our new equation. And from the question, we were told that what? The relationship between this roots were what? 3. That is 3 times of the root of this equation. Now, if you really want to confirm this, then you can use your calculator to find the roots of this. So we have our x squared minus 2x minus 5 is equal to 0. If you have to solve for this, you are going to get x, which is equal to a 1, then minus the root of 6. And then you have x is also equal to 1 plus the root of 6. Now for this new equation we have here, the root of this equation, that is x squared minus 6x minus 45 is equal to 0. Its roots are what? X equals 3 minus 3 root 6. Then x is also equal to 3 plus 3 root 6. If you have to factorize the 3 out, we have 3 into bracket 1 minus root 6. And the same applies here. 3 into bracket 1 plus root 6. If you look at this too, you realize that this is 3 times the product of the first one we had right here. And that confirms what the question said. You see how they relate to each other? Yes. So this is one interesting way we can solve symmetric functions using the sum and then the product of roots. Now, as I said earlier on, there are some expressions that you should know how to solve them. For such, I'll give you their formulas so you can easily make reference to them. As I said earlier on, there are some symmetric expressions that when you are asked, you need to know how to rewrite them. For instance, when we're given 1 over a, that is 1 over alpha plus 1 over b, you see we're easily able to evaluate it as alpha plus beta over alpha beta. That is the sum over the product of root. What if you are given 1 over alpha squared plus 1 over beta squared? So with that as well, you have to evaluate it and then get alpha plus beta all squared minus 2 alpha beta all over alpha beta all squared. If you know this expression, there's no need going to try to prove it. You can just do your substitution and quickly go. So with that, you get your sum of roots here. Then you know where to put the product of roots. And you also know where to put the product of roots here as well. If you are given alpha squared plus beta squared, you also know what to do as well. So let's solve a question that would need us to come back to this reference table. So looking at our next question we have here, it says find alpha minus beta all squared for the equation 2x squared minus 7x plus 3 is equal to 0. Hence, we have to find alpha minus beta. Our equation was given as what? 2x squared then minus 7x plus 3 is equal to 0. So first of all, we need alpha minus beta all squared. Now from our table, alpha minus beta all squared is given as what? Alpha plus beta all squared then minus 4 alpha beta. So we need the value of alpha plus beta, and we also need the value of alpha beta. That is the sum of roots and the product of roots. So with that, we'll have to go back to our equation. That is 2x squared minus 7x plus 3 is equal to 0. Before we can get our alpha plus beta, that is the sum of root and then the product of roots, the coefficient of x squared needs to be 1. So we have to divide each and every term by 2. So that we have x squared minus 7 over 2x, then plus 3 over 2 is equal to 0. By now, you should know how to get your sum of roots and then a product of roots. So comparing, we have negative sum of roots equals what we have over here. Hence, the sum of roots, which is alpha plus beta, is then going to be 7 over 2. You know there's a negative here, and this also has negative, so they both cancel out. Then we can also say the product of roots, alpha beta, is also equal to 3 over 2. So if you're able to get this, we now come back to what we are to look for. So it simply implies that alpha minus beta all squared is now equal to, it says the sum of roots squared. This is the sum of roots. So you have 7 over 2 all squared, then minus 4 times the product of roots. So the product was what? 3 over 2. If you have to simplify this further, then we can say our alpha minus beta all squared is simply equal to, the squared affects both the numerator and then the denominator. So we have 7 squared, which gives us a 49 all over 2 squared, which is also a 4. Then this 2 divides this 4 to give us 2. So we have 2 times 3, which is a minus 6. So 49 over 4 minus 6 then gives us a 25 over 4 as our alpha minus beta all squared. So with that, the first part of the question has been solved. We have found alpha minus beta all squared. Now the next part says, what is alpha minus beta? If we have alpha minus beta all squared and we want alpha minus beta, then we should just find the square root of both sides. You see, so let's find the square root of both sides. If you have to find the square root of both sides, what happens? This square root takes out the squared, and then you have alpha minus beta. From the laws of indices, this simply means the square root of 25 over the square root of 4. So our alpha minus beta is then equal to, anytime we find square root, we have two possible values. So a plus or minus the square root of 25, which gives us a 5 all over 2. This is our answer. So therefore, what have we been able to prove? That alpha minus beta all squared is equal to a 25 over 4. And then alpha minus beta is also equal to a plus or minus 5 over 2. And that is all. So all we are trying to say is, with this symmetric expressions, if you are able to keep this in memory, or if you can easily always generate them, you can solve for other symmetric functions as well. And what do? You always try your best to identify your alpha plus beta, then alpha beta if they both exist in it, and then you do your appropriate substitutions and then solve. Now let's conclude this by solving a last question that is on application. It is a real world problem. Our last question we have here says, the sum of two numbers is 12 and their product is 27. Find the numbers by constructing a quadratic equation using symmetric properties. This is a very interesting one. How do we go about this? So is there a sum? You see, there's a sum and then a product. Let's let the two numbers be alpha and beta. So we say let the two numbers, right? The two of the numbers be alpha and then beta. And we are given that the sum of the numbers is 12. So alpha plus beta is equal to 12. And then their product, alpha beta, is equal to what? 27. This is what we have. Now with this, we can form a quadratic equation with the sum and then the product. We know for alpha and beta, the quadratic equation is given as x squared then minus the sum of the roots x and then plus the product of the roots should give us what? 0. So let's do our necessary substitution. We have our x squared minus the sum of the root was 12. So minus 12x, then plus the product of the root was 27. So plus 27 is equal to 0. We then need to factorize it. So you can either use your formula, the quadratic, that is the quadratic formula, or the completing of squares, or the factorization method, all of which we have done in our playlist. If you have to factorize this, you are going to get an x minus 3 and then an x minus 9, which is equal to 0. Solving for x, you are going to get an x equals 3 or x equals 9. So it says you have to find the numbers. These are the numbers. You see, so we say therefore the numbers are what? They are 3 and 9. So you realize that if you add 3 to 9, you get your 12. And if you multiply 3 by 9, you'd also get a 27. As simple as that. So that concludes this lesson on the symmetric properties of roots. That is the sum and product of roots. As usual, I'll leave with some exercises so you try on your own to test your understanding. So here we have 6 questions based on all that we've done so far in this lesson. I do hope you'll be able to find solutions to them. If there's any issue of concern, you can always let me know at the comment section. When I'm notified, I would quickly attend to it. If this is your first time on this channel and you so do wish, you can subscribe so that anytime I release a video, you'll be notified as well. See you in our next lesson, and bye for now. Do stay safe.